Good morning. My name is Abang Daniel Hakimi bin Abang Muhazan. Matrix number 103043. Today, we will be presenting our group project for TMF1254, titled Communication and Computer Network. These are three main objectives for Part A. First, to understand the effect of network parameters on ARQ performance. Second, to interpret simulation results using charts and graphs, allowing us to compare the behavior of different ARQ protocols. Last but not least, to analyze how variations in packet loss, latency, and window size can impact overall performance. I will introduce about ARQ protocols and flow control. ARQ stands for Automatic Repeat Request. It is a network mechanism designed to ensure accurate and reliable data transmission. There are several ARQ protocols, such as stop and wait, go back and selective repeat. These protocols help to detect and correct errors during data transfer. If any data acknowledgements, also known as ACK, are lost or corrupted, ARQ automatically transmit the affected packets. In summary, ARQ protocols play a crucial role in maintaining reliable communication in network. Now, let's look at the importance of flow control. Flow control makes sure that the sender does not overwhelm the receiver with too much data at once. This helps prevent packet loss due to buffer overflow and keeps the network efficient and stable. When we combine ARQ and flow control, we can achieve safe, efficient, and consistent communication in modern networks. So, flow control is really essential for reliable data transmission. I will briefly explain three main data transmission protocols. First, stop and wait. Stop and wait. This method sends one packet at a time and waits for an acknowledgement that we call SCK before sending the next packet. It is simple but can be slow because each packet must be confirmed before continuing. Go back and this protocol allows multiple packets to be sent before needing an acknowledgement. However, if an error occurs, all packets from the point of error onwards must be transmitted, which can reduce efficiency. Second, selective repeat, like go back and this method send multiple packets but only retransmit the packet that were lost and corrupted. This increases efficiency by avoiding unnecessary retransmission. In summary, each protocol has its own strengths and weaknesses in ensuring reliable and efficient data transmission.
Hi, my name is Izan. My metric number is 105240. This slide shows the experimental setup we used to analyze the performance of the RQ protocol. So we designed for different scenarios. For scenario 1, no packet loss, high bandwidth. In this scenario, we simulate a stable network with only 1% packet and SCK loss, high bandwidth of 100 Mbps and low latency of 0.1 millisecond. For scenario 2, high packet loss and low bandwidth. Scenario 2 simulates an unreliable network with 30% packet loss but only 1% SCK loss. Bandwidth is kept at 100 Mbps, but frequent packet loss introduces high retransmission pressure on the protocol. For scenario 3, high latency with different timeout interval. Here we focus on latency effect. We test how each protocol performs under a high latency environment by changing timeout interval to 5 milliseconds and 1000 milliseconds. For scenario 4, wearing Windows side for go back and selective repeat. This final scenario tests the impact of different Windows size, especially size 5 and 10. So for scenario 1, with low packet loss and high bandwidth, we observe clear performance difference. For stop and wait, had the lowest throughput at 52.41 Mbps and higher processing overhead due to frequent waiting. So for go back end, perform better, reaching 207.69 Mbps with minimal retransmission and lower overhead. The last one, selective repeat, was the most efficient. achieving 218.18 Mbps throughput with no retransmission and 0% processing overhead. So under ideal condition, selective repeat give the best performance. So for scenario 2, with high packet loss and lower bandwidth, stop and wait show the worst performance with only 15.38 Mbps and high retransmission, causing 50% processing overhead. For go back N, did better at 37.59 Mbps but still had many retransmission. For selective repeat was the most efficient again, achieving 81.82 Mbps throughput with fewer retransmission and lower overhead. So even in tough network conditions, selective repeat remained the most reliable and efficient. So for the third one, scenario 3 with higher latency and a short timeout of 5 milliseconds, stop and wait had very low throughput at only 0.02 Mbps due to excessive waiting time. For go back and improve slightly with 0.07 Mbps but still experience 6 retransmission. For the last one, selective repeat performed the best, achieving 0.09 Mbps with lower overhead and fewer retransmission. This shows the selective repeat handle high latency network more efficiently than the other. So for timeout 1000, for stop and wait, show the lowest latency 0.02 ms but the lowest throughput 51.012 Mbps with a packet loss of 2%. For go backend and selective repeat have a higher latency 0.09 ms but more stable throughput 4725 Mbps. Selective repeat stand out with the highest efficiency to 5 units compared to go back and 1 unit, making it the optimal choice for high-speed network. So a timeout that is too long causes the sender to wait a long time before retransmission, even if the packet is lost or the SCK is not received. This result is high idle time and a longer overall transmission time. Throughput decreases because the waiting time for the timeout is long, even when there are transmission problems. Stop and wait is the most affected because it depends on one packet and one SCK only. The longer the timeout, the slower the overall retransmission. So for the last one, scenario 4, for go back end with a window size of 1, the throughput is 54.55 Mbps with bandwidth utilization of 54.55%. There are no retransmission and the processing overhead is 0%. Meanwhile, selective repeat, also with a window size of 1, show a slightly lower throughput of 52.41 Mbps and bandwidth utilization of 52.41%. However, there are two retransmission and a processing overhead of 1.96%. So go back and delivers slightly better performance in this scenario with no retransmission and minimal overhead, while selective repeat incur some additional costs in terms of retransmission and processing. So for size window 10, we get highest throughput for go back end is 406.99 Mbps. We get very short transmission time is 0.00286, and we get retransmission 3 and SQL loss 1 increase slightly, but overall performance is better. So for selective repeat, we get highest throughput of all 445.45 Mbps. We get shortest transmission time is 0.00264, and we get retransmission 2 and SQL loss 1 and still low. So selective repeat consistently outperform go backend in all Windows sites due to its ability to manage retransmission more intelligently. So large window size such as 5 or 10 are suitable for use in stable network because they increase retransmission efficiency. So however, the risk of retransmission and ACK loss increases significantly at larger window size, especially in go backend due to more packets being sent simultaneously without acknowledgement.
Hello, my name is Muhammad Manikim Susham, and now let's move on to the analysis and discussion on how different network conditions affect protocol performance. Okay, so this aspect we're going to discuss two aspects key, which is the first one packet loss, and the second one is high bandwidth. Okay, so this factor is going to be impact on how stop and wait, go and back, and selective repeat protocols perform under a various. Okay, so the first one is packet loss. So packet loss, let's consider it network experiencing 10% loss. So stop and wait struggle the most because it reduces transmit frequency, so it's gonna be lowering the throughput. Okay, so for the go back end, perform slightly better, but still resend all the packet after a loss. So this is a way full. So the best one, selective repeat is the most efficient here, as it's only transmit the lost packet. So in high loss environment, selective repeat is the clearly better choice. Okay. For the second one, I'm going to be explain is high bandwidth. So high bandwidth in the high bandwidth network, for example, 10 Mbps, stop and wait, you utilize the capacity since it wait for an ACK after every packet. So go back and selective repeat takes the advantage of the window-based transmission. So this means multiple packets can be transit seamlessly, resulting in a higher efficiency and throughput. Okay, for the high intensity, okay, such as satellite networks where the latency exceeds 500 milliseconds, so stop and waits become impractical due to the long waiting times, so it's going to be very slow. So go back and select it, repeat, perform much better here as they allow sending multiple packets without waiting for individual SDKs. Okay, for the next one is timeout too short or too long. Okay, so timeout setting are also critical. So if the timeout too short, so let's say 505 milliseconds. So it is too long, like 1000 milliseconds. So it's going to be recovery from the packet loss become very slow. So selective repeat against push more robust here as is handled as a case and packet more intelligently with moderate timeout. Okay, for the overall conclusion, so selective repeat is the most efficient and versatile across the different network conditions. And go back end is more efficient than stop and wait, but it is not optimal in the high loss or high latency network. So stop and wait is simplest but this efficient. Ultimately, the right protocol depend on the specific network environment such as latency, loss rate, and bandwidth availability. Okay, now so let's move on to the part B of our presentation, which is network design. So here we design a practical network solution for NAMI signal berhad based on their requirement. Okay, so the main objective is to create a stable, reliable network for NAMI signal berhad. So we aim to design the network that fits the organization size and needs. And second one, recommend whether to use wire or wireless technology to connect both pieces. And the third one is to ensure that the solution is cost effective while still handling the expected data traffic efficiently.
Hi, my name is Nur Azwan Najla binti Ismi. My metric number is 105566. As you can see, this is the proposed network design for Nazmi Sendirian Berhad. There are two offices, namely Office A and Office B, each equipped with various network devices such as PCs, laptops, printers, and wireless devices. On the left side is Office A, level 1, There are 15 desktop PCs and 5 mobile laptops. 2 printers are shared by all users in this office. Limited Wi-Fi access is provided in the meeting room for guests. And then, on the right side is Office B Level 2. There are 10 desktop PCs and 3 mobile laptops. 1 printer is shared by all users in this office. Wi-Fi is also provided in the meeting room for guests. As can be seen, Office A has 2 printers while Office B has only 1 printer. This is because only Office A has more users with 15 desktop PCs and 5 mobile laptops. With a higher number of users, more printers are needed to ensure the workload is handled efficiently. The router 2911 functions as the main connection point between Office A and Office B. It ensures that both offices can access the internet through a single ISP connection. Without this router, the two offices would not be able to communicate with each other over the wide area network, and it will also be unable to access the internet. And this router functions to route traffic between two subnets. For example, it connects two different subnets, which is Office A and Office B, each with its own local area network. Therefore, the router ensures that data is sent and received correctly between the two offices, even though they are located in different places. This router is also responsible for controlling the traffic that enters and exits the company's network. It ensures that every piece of data sent to and from the network is authorized based on the network's policies and requirements. For example, if there is a request to browse a website, the router will direct that traffic through a single gateway specified by the ISP, thus ensuring a stable flow of internet traffic. Next, 2960-2040 switch. This switch is a network device that connects all devices within a LAN in each office. It ensures that every PC, laptop, and printer within an office can communicate with each other in an organized and efficient manner. The switch directs data specifically to the device that needs it. This reduces bandwidth wastage and minimizes network interference. In this way, the internal network performance becomes more stable and faster, especially when many devices are connected at the same time. The wireless router provides Wi-Fi connectivity to mobile devices such as laptops, smartphones, and tablets. This allows mobile workers, such as those using laptops or phones, to work without being tied down by cables. This router provides Wi-Fi access not only for mobile workers, but also for guests visiting the office, especially in the meeting room. This ensures that even when employees are away from their desk, they can still access the company network and stay connected with it. This router also serves as an access point within the network. This means it allows other devices on the network to connect wirelessly, enabling more devices to be connected at the same time. This router is important because it provides essential wireless connectivity in today's fast-paced and flexible world, where employees often move between rooms or even outside the office. PCPT. This PC functions as the main work device for employees working in the office. It is used for various daily tasks, such as processing documents, sending emails, and accessing shared servers and printers within the company network. Employees use this PC as their workstation to complete daily tasks. Their needs may include carrying out administration duties, processing important documents, or communicating with other teams via email or internal platforms. This PC is connected to the network via an Ethernet cable, providing a wired connection. A wired connection is more stable and faster compared to Wi-Fi, ensuring that employees can access data and service quickly without being affected by latency issues or connection drops that may occur with Wi-Fi. Laptop. This laptop is a portable computing device used by mobile employees who work away from their office desks or those working in a hybrid or remote mode. This laptop connects to the network wirelessly through the wireless router, allowing mobile employees to easily access the company network without being tied to cables. This is important to ensure smooth mobility as employees move around the office or work from different locations. By using this laptop connected to the company network, employees can work flexibly either from the office or from home, depending on their needs. This also gives the company the freedom to adapt to hybrid work requirements. Printer. This printer is an output device used to print important documents required for the daily operations of the office. This printer is shared by all users within their respective office through the network. This means that each employee can send documents to the printer from any PC or laptop connected to the network, enhancing efficiency and convenience. This printer is directly connected to the switch within the network, allowing universal access to all devices on that network. This ensures that the printer can be used by all employees without the need for a direct or physical connection to the printer. Okay, now this section explains the guest Wi-Fi access provided to ensure network security and efficient performance for Narmi Sendirian Berhad. First, two separate SSIDs are provided with office Wi-Fi or for employees and guest Wi-Fi for guests. This SSID separation ensures that guests can only access the internet while employees have secure access to the company's internet network. That enhances the protection of the internal network as guests don't have access to more sensitive company resources. VLAN, Virtual Local Area Network. VLAN divides the network into several logical segments. In this case, guests are only allowed to access the internet, while employees can access the company's internal resources such as servers, database, and other services. This enhances security and traffic management as each group is on a separate network even though they share the same infrastructure. Then limited access or access control. Guest access is strictly controlled to ensure they can only use the internet and have no access to the company's internet network. Then, Bandwidth limits can be enforced to prevent excessive usage or any negative impact on overall network performance. This traffic separation ensures that guest data doesn't interfere with the internal employee network. A firewall is used to block any unwanted or harmful access, thereby ensuring the security of the company's network is well protected. Next, guest access portal. This portal controls guest access through security protocols such as WPA2, WPA3, bandwidth limits, and restrictions that allow access to the internet only. This ensures that guests cannot access the company's internet network, preventing any security risks that could arise if they were able to access sensitive data. And the last one is guest network traffic separation. This traffic separation ensures that data from guests doesn't interfere with internet network. It uses a firewall to block any unwanted access and ensures that guest traffic remains isolated from employee network traffic.
Hi, my name is Nur Fadila Ain and my matrix number is 105798. I will continue the presentation at why use wire connection for PC. First is stability and high speed. Wire connection offer more stable and faster internet and local network performance compared to wireless. Second is security. Wire networks are inherently more secure since physical access to the cable is required, unlike Wi-Fi, which can be accessed if not properly secure. Third is less interference. Wire connections are not affected by signal interference or obstacles such as walls or other electronic device. Four is fixed location. PC a typical stationary, so setting up permanent wire connection is more logical and cost effective in the long term. Next, why use wireless for laptops and guests? First is mobility. Laptop and guest user often move around. Wi-Fi provides the need flexibility without requiring physical cables. Second is cost saving on cabling. There's no need to run Ethernet cables to every laptop or guest device. Reduce installation and maintenance costs. Third is guest access. Dedicated guest Wi-Fi network (SSID) can be configured with access control and ensure security. Four is device compatibility. Most modern devices like phone and tablets rely on wireless connection, making Wi-Fi a practical necessity. Why use one ISP and router to reduce costs? First is simplify management. Only one internet connection and one router need to be managed. Two is lower ISP subscription costs. There's no need for multiple internet plan and one ISP can serve the entire network. Third is efficient routing with the Cisco 2911 router. This router supports advanced features such as VLANs, DHCP, and AT and can handle traffic from both networks efficiently. Four is reduce equipment needs. Using one set of network device like router and modem save space and reduce power usage. Other justification first, why we use of layer 2 switch Cisco 2960. This allows centralized connection of many PC, simplify cable management and make troubleshooting easy. Second, why we use of wireless router WR340N. This is because provide wireless access for laptop and guest in different network segment. Third is network printers. Directly connection to switch allowing all PC and laptops on the network to access the printer without needing USB connection. Estimate cost for this project. First, Cisco 2911 router for 1 unit is 2,500. Cisco 2960 switch for 1 unit is RM 1000 and for 2 unit is 2000. For WR340N wireless router for 1 unit is 150 and total for 2 unit is 300. Internet cables Cat6 RM 1 ringgit per meter and for 300 meter is RM 300. PC for 1 unit is RM 1,500 and 37,500 for 25 unit. Laptop for 1 unit is 2,000 and total for 8 unit is RM 60,000. Network printer for 1 unit is RM 500 and RM 1,500 for 3 unit. Total estimate for this project is 16,100. After that, practicality. Easy maintenance. Fixed infrastructure allow for easy network monitoring and troubleshooting. Second is scalable, easy to expand in the future by adding more switches or access point. Third is cost effective, efficient use of resource, high speed connection for fixed device and noise flexibility for portable or guest device. Conclusion: this network design provides a practical and cost-efficient solution that balances high performance and flexibility. Using wire connection for PC ensure reliable and fast access, while wireless access support mobile device and guest effectively. Centralizing internet access through a single ISP and router simplifies management and reduces costs. The overall system is scalable, manageable, and well suited for office, lab, or education environment.